Have you reviewed the prerequired skills for the
Yeah, I
next
remember.
chapter? Remember?
Yeah.
Okay, so today is gonna be a relaxed class for us. We're gonna practice doing this type of problem solving, okay?
Mm-hmm.
And it's gonna be pretty straightforward. You're gonna do it actually. And I would like you to explain your solution, okay? And show me how would you write it, or at least say how to write it. Be able to explain the solution, okay?
Are you supposed to be screen sharing something?
No, not yet.
Okay.
Just get yourself prepared. How would you write it? Think about it. Last time I remember you didn't had a paper, this graphing paper. Because now we're going to sketch the graph.
Mm-hmm.
Can you draw on are you using PC platform or are you using smartphone?
Mac.
Mac?
Yeah.
I'm pretty sure you can draw on the screen.
Not really good with technology. Don't really know how, but I have I did get graphing paper from school. I like graphing cue cards.
So I'm going to screen share now. Can you see it?
Yep.
We're going to work through it slowly, no rush. So guys, take a look at this equations.
Can you go back to the first slide for a second?
Yep.
Just want to see which lesson this is. Chapter 3.
Chapter 3.0. So Yusuf, how are you feeling about doing first step into problem solving today?
The first one? Okay.
Wait a second. Let me just get a pencil.
Yeah. Take your time,
Oh.
Alan. Yusuf,
Yeah.
so
So for the first
are
one,
you
A,
ready? No, which one would you like to solve?
I can do A.
You would like to do A?
Yeah.
Let's do it.
So should I just say or like write?
You can say.
Okay. So first,
But I'm going to write what you're saying, but I want you to explain it in order, right?
yeah.
How would you express it on the paper? Because that's essentially what you need to be able to do.
Yeah. Okay.
Just
So
give me a
first,
second.
I'm back, by the
Okay.
way.
Oh, perfect. Let's. Yusuf,
yeah.
explain A.
So first, to find the x-intercept, I would sub y equals 0 and then calculate the product. Then I would like remove the 0 and then move the constant to the right. And then to remove the x, so divide both sides. So then wait, I'll just calculate it with my calculator fast to see the answer. So it will be x equals 3. That's for the x-intercept. And then for the y-intercept, I would just sub x equals y and then just solve it. So that would be it would be y equals 2.
Yusuf.
Yeah.
So you said it's when
So
y equals 0 and
no,
x equals 3.
I
It's
said
the first. It's the
what?
first point that we have, right?
Oh, the first point. No, I meant like that was the y-intercept. So the y-intercept is 2. And the x-intercept is 3. That's what I meant.
But you're just
And then it's a
I
linear
I don't
function, so
but what about sketching the graph? Where is sketching the graph? Y-intercept, x-intercept. What is it? What is y-intersect? What does it mean? What should I draw on the sketch? You're supposed to sketch the graph,
okay,
represent
so
it, be able to see the equation as a set of values on a discrete
yeah.
system when you have x and y.
So for the
So you said that we're finding the y and x intercepts
yeah,
of this function. We're simplifying it. We're moving constants from left to right.
yeah. So then
So but the first step, I see this equation. What I do with it?
so the first step is to find the x-intercept or the y-intercept, it doesn't matter, but oh well actually the first step is to see if the equation is linear or not. What type of equation is it?
Yeah, that's good. That's good idea. So now we definitely can see that we have only first power in here, and it most likely is gonna be a line.
Yeah,
Most definitely it's gonna be a line. So we just need to find one point and the angle at which this line is passing this point, basically.
yeah,
One of the approaches. And the second one is just to find the solution that we can. And if we know two solutions for this equation, then we're gonna get a pair of 2 points, and we know if we draw a line through 2 points, it's always gonna be the line, the graph that we're
yeah.
looking. So which approach do you choose now?
So if we to like a point we can get is the x-intercept and the y-intercept. Those would be 2 points, and
Okay,
if we plot these down, it would show us the whole graph.
okay. So first, we should find the value of x
Yeah, so the
when it
x
satisfies that y equals
and
0.
yeah, and the y-intercept is 2 and the x-intercept is 3.
Uh, yeah, great idea. But why don't you look at this at another perspective? Did in your solution, maybe I didn't hear it. Did you substitute value of y somehow?
Yeah,
You substituted it for 0, right?
yeah. I
And you get
substituted y for 0.
2x plus 2x subtract 6 equals 0.
Yeah,
Great. That's what I want to hear.
Yeah, that's for like the first step that I did to find the x-intercept.
Great. Y-intercept you said?
It's 2.
2. Great. So now we go to the sketch.
Yeah.
So let's now implement the order and the numbered pairs, because for example, you see now if you look here, it just 2 pairs
2
in the
pairs. Yeah.
square. Like, how should I read them? Should I read them like this, or maybe should I read them like this? You need to clarify it when you're talking about points and graphs. So this would be, for example, x, y, so intercept, y-intercept.
Yeah.
Or it's even better to say, because eventually we're looking for pair of 2 points, right? So
Yeah.
it would be x1 and y1 and y2 and x2.
X2. Yeah.
And that look, now it's more clear to me that this is pair of 2 and this one. Because later on, imagine working with something that has greater power. We would have to study more properties of such functions to be able to sketch them. Because what you're doing now is just finding values at few points and then drawing the graph, right? But eventually it's not enough to solve any equation, because what if the graph is going to be looking like this? If it's going to look like this, you cannot find just 2 points and say it looks like this.
Yeah. So the first thing we needed to do is to identify what type of equation, what type of graph it's going to.
Yes, great, and that's what you said.
Yeah.
But I'm just introducing you into what we're going to learn, because what you studied before was sketching graphs in this way, and we will cover some more advanced methods.
Okay. Yeah.
For example, one of them I would like to make you a quick, insight. So let's take a look at the equation E, okay?
Okay.
Now we would got this line for A. Yusuf, congratulations, you're super right. Look here. Here we have a quadrant equation. So it would be y equals x squared subtract 4. And what would you do in this case? Well, how would you start doing it?
For E, first is to identify what type of graph it would be.
Okay.
So for this one, it would be just parabola. It's a quadratic function,
Okay.
and because it's negative, it would open like upwards.
Okay. No, it's
Like
not negative.
no, because it's negative. It's because it's
It's
because
because it's positive. It's
it's
gonna look
positive. Yeah.
upwards.
Yeah. So it would
We
open.
look at the coefficient in front of the x.
Yeah.
Great. So, and then you would
And
try
then
to,
find the vertex.
how would you find it?
So to find the vertex is first I would substitute the coefficients to the expression, and then just like solve until like y equals a number. Like I'm going to do it on paper, just 1 second.
Like you would go through set of tries and errors?
No, it's like so first is to like identify the coefficients like a and b of the quadratic function. Then I would like find the x coordinate of the vertex by substituting like a yeah, a and b equals 0 into like I forgot what the formula was. There was a formula for it. It was like b over something.
I believe there was b over square root of something.
Negative b over 2a.
Yeah. Negative b over 2a, yeah, that was that one. So substitute the
And
equations into
negative b over 2a, what it gives us.
it's to solve the function, it's to get the vertex.
You know,
Well, it's to find the y value of the vertex.
Yeah,
And then you plug the y value back into it and you get the x.
wow. How much time do you think we're gonna spend on it? Are you solving it?
I'm solving it right now. I almost have the answer. Yeah.
And while you're solving it, I'm gonna show you my method.
Okay.
So what I know about equations, that they grow, they decrease, they change their velocity, they have different acceleration. And I know about parabola, in fact, that at some point it changes her direction. So I can make a statement that at the point where derivative of this function is going to be equal to 0 would be the vertex. So it would be the tangent, let's say it would look like this. So the tangent line to the furthest point on this graph would have derivative equals 0 because it would be just parallel to the x-axis. Remember, derivative, it's in fact what? Derivative is a way of finding the
Yeah.
slope of a tangent line to the curve at the point.
Oh.
And what is the slope of the horizontal line?
0.
In fact. So now I say I just need to find derivative of this one and find its value when it's equals 0. And derivative of this one is pretty simple to find. Derivative of y would be 2x and just 2x. So now I just need to solve it for 0. Wait. Yep. So now I say derivative equals 0 equals to x. So x equals 0. And now I go to this equation to find y, the point y, okay? The value of y, where it is. And you see, here I should get -4. So it would be the point x0, y -4.
Yeah.
And so this is the point A, 0, -4. And in this point, function, in this case, reaches its minimum. You see? Basically. Because we know its property, how this exponential function looks like. So now you know this point. Next step, you know that from this point, based on that coefficient of this function is positive, it's going to look upwards. So you take 2 points from left and right from the x equals 0. You can take x equals 1, x equals -1, x equals 2, and x equals -2. Now you find 2 additional points on the graph. And now you can simply sketch it through these points, right? Look. This would be your solution without prior to sketching the graph. We found A, whereas a tangent line goes at the 0 angle or vertical to the x-axis. And now you know that through 3 points, we can pretty accurately sketch the exponential function. Do you understand what I'm explaining here?
Mm,
Yeah, I think I do. Yeah.
Ask me a question, please.
Can you explain the last step?
So, first step was to, oh, you got first step, right?
You find the derivative.
Find the derivative, substitute it when you want a derivative be equal to 0. Find this x, because you know, tangent line touches the curve at one point, and the value of x would be this point where line is passing through the curve. And now we just need to find y coordinate of this function. We substitute x for 0 in this particular case. In another function, it may be different.
Well, yeah.
So another function would have different derivative. Function of another, we would just find the common point, but the derivative itself would not be a line. It would be another graph. Remember, we sketched derivative of a function that has the greatest power of 3. It was hyperbola. And we already studied that derivative of second power is a line. And that derivative of every power is just this power minus 1. Now we connect it together, and now we can actually plot it on the graph. And it's a really important, the derivative has connection with the graph. It shares the same point with the graph.
Mm.
So you see, basically my solution takes 2 lines, because you know exponent rule for derivatives. It's simple. And you know coefficient rule for derivatives. And you don't need to go to A, B, C. You can do it faster and more efficiently. But now, Alan, can you solve another graph for us? And we're gonna have
Sure.
a break.
Sure. Which one? Do I choose?
I will choose for you. Let's sketch this one.
Oh, that one's a parent function. That one's easy.
This one easy?
Well,
Or you
it's-
can tell me what to draw.
yeah. It's a square root function, so it's gonna start at 0,
Okay.
and there's no transformation to it, so it's just the parent function. So it would start at 0, and then it would go to 1 1, and it goes to I think 1 1 2 1 2 2. Give me a second. I'm just trying to picture it because we had to memorize these in my grade.
Let's substitute x for 4 when we would get y equals 2.
Yeah, y equals 2, and it would be at 2, wouldn't it?
Now it's pretty much enough,
Four.
because we know that it looks like this.
Yeah.
You see? Great job. Let's not waste time on this anymore. Let's move on to another example. I see that you have your skills from past courses about this, so let's not waste time. But we're gonna look into better ways, better solutions. Oh, here. Solve each equation. We won't solve each equation. Let's just solve few of them. Let's solve a higher grade. Do you feel confident about this one?
Let's just do an example. One. Oh, this one? Yeah.
Yeah. How would you do it?
When you mean solve, you mean like find one number or simplify it?
Find the solution. Find values when it's true.
Okay. Synthetic division we could do. So actually no, we could easily do this. You just factor out an x. And then you could product sum. So what multiplies to -3 and adds to 2? Well, you have x equals 0. But
Is that the only solution?
I think that's a possibility, but let me just find it. Give me a second.
So yeah, in this case, you're true because if we would have x in denominator, we wouldn't be able to say that x equals 0, remember? Because otherwise we would have problem of infinity.
Yeah.
And in fact, you've been told that if you divide by 0, you get infinity, right?
Yeah, I got
But-
the answer, by the way.
Huh?
I got the answer.
Well, okay, how?
It's gonna be x. Well, so if you can I write on this?
You can write.
So you have the p, which is product. Oh, why is it erasing when I'm writing? Thank you. P equals product, and that's just these two multiplied, and then you get -3. And then you have your sum, which is just your b value. And that equals 2. And then you want to find two numbers that multiply to the product and then add to the sum. That's -3. No, sorry, -1 and 3. And you could do that method where you do decomposition, but I prefer this method, this other method myself. They taught us it at school. You
Yeah, that's good method. It's actually called the Vieta theorem.
we call it the Aussie method.
It's called the Vieta theorem. Because it goes from x1 times x2 equals
This, yeah. We call it the product sum.
yeah, it's another word, but Vieta is what it was the name of the mathematician who found this solution.
Well, that's the answer. So then x could equal 0, 1, and -3.
Wait, are you sure it's the right solution? Because I remember there was product is equals C or minus C.
No, I'm positive this is right.
So product equals C and sum equals B.
Yeah. Well, product equals A times C.
And sum equals minus B.
No, equals B.
Let me check it, okay? So I have sum equals minus B and product equals C.
I think it's a different method than what I learned.
If you have A that is some coefficient that is arbitrary value, it would be x, so x1 plus x2, two solutions equals minus b divided by a, and x1 times x2 would be equal c divided by a. But let's see if we get the same answer in this way. Because there could be no other two solutions, you understand? This method either works or it doesn't. So in this case, we would have x1 times x2 minus 3 divided by a 1, and
Yeah, it works.
minus b divided by a would be minus 2. So we can make a statement that it most likely minus 3 and 1. But you see, only difference that you have 2 and I have negative 2.
Yeah, but both methods I think work.
But let's implement this.
Oh wait.
But
Oh, I just checked my numbers and they all equal to 0.
what?
Like I just took the numbers here I got and they all equal to 0 when I put it back in the equation. So x is equal to 0. And then I got here x is equal to 1. And then here's x
What
equals to,
numbers? I don't get it.
I plugged these back into the equation here, and they all equal to 0.
Um, and what does it mean?
It means it works, it's right.
If you plug in -1, it works. Wait.
No, if it's 1.
So let me see. Minus. Look, both methods are right. They're getting the same
Oh yeah,
answer.
yeah. I'm just saying my method. I didn't check the numbers you got.
Yes, yeah, I see. But that's what we are looking for. That's solutions when the equation equals 0. So what are the solutions in this case? There are 3 solutions?
Yeah, x equals 0, x equals 1, x equals -3.
Perfect. How would you treat this one with force power? Yusuf, maybe Yusuf, if you don't mind, Alan.
For which one, sorry?
For I.
Okay, I'm not sure exactly how to start.
I know a method I could use, but I don't know if
Any ideas, guys?
I have an idea.
Let's think about it.
I could do it, I think. Can I try?
Let's ask Yusuf.
Okay.
Yusuf?
I'm not sure exactly.
No, guess. It's okay. We're not looking for a right answer. We just want like to solve it.
I think I would like
Let's try. Let's do what we know. Have you learned substitution of the variable? When you substitute the variable for
Oh, yeah, so,
another variable?
yeah, so you'd substitute it for t, right? Well, it's, wait, no, it's already t, sorry.
We can substitute it for t square equals
Yeah.
something, solve it for that case, and then find the root. And that's how we're gonna find t.
I have another method I could use.
Okay.
Can I show you?
No, wait. So I didn't heard Yusuf's sample.
Oh,
Sorry,
okay.
I interrupted him. I also
Okay.
interrupted you with my idea because I'm also excited about it. So how would you do it, Yusuf? Any ideas? Maybe let's what we have here. What type of equation is that?
Well,
Uh,
it's, I have no idea, I'm not sure.
well, we can definitely say it's exponential.
Yeah,
Well, you say whenever you see something that is scary, you break it down into pieces. We see that here, for example, t belongs to all real numbers. So we can chill out. Real numbers are not scary. They all exist. You should trust them. Most likely, if you are not dividing by something, you shouldn't be scared. Because when you divide, that's when this scary divide by zero approaches you. But here we have just a sum and difference. Here we also see we have difference of a product. Oh, sorry, difference of a second power. We can write it as 2 times t square subtract square root of 13 t, and here times 2t square plus square root 13t. And this is now just a what is called simple square function, right? We already know how to solve them. But here we have scary plus 9.
Hmm. Okay. This method, I understand it. It's just it's complicated.
No, but it's not solved in this way.
Yeah, I know.
So, for example, what if we implement derivatives in here? What do you think, guys?
X.
When we just need to check if derivative may exist for this function. Remember? We
Yeah.
have to determine if derivative exists. For some function, derivative does not exist at some range when we have x greater than or less than, for example.
I mean, why wouldn't it?
Huh?
Why wouldn't it exist for this equation? If you get the if you get the derivative of the first one, you use the power rule, you get 4t subtract what's derivative of 13 squared square root of 13t?
square root of 13.
No, the derivative of
It would
13.
derivative would be square root of 13 because it's derivative of constant multiple rule. Remember, this is the constant multiplied by function, and constant stays, and function treated as normal. In this case, as exponential. In this case, power is 1, so derivative would be t to the power 0 equals 1,
Oh,
so square root of 13.
okay.
But you cannot do that. You can do it at this step. You don't need to do it here
Oh.
because now you're supposed to treat it as product of two functions.
So if you do it there, you would get 16t cubed subtract 26t plus 9.
No.
Oh, 0.
Yes.
So it would be that would, and then you could factor out a t, and you get 16t squared subtract 26, and then you could solve that. Can you could factor out a 2. Should we?
FOT.
Should we factor out a 2?
Yeah, we can to simplify it a little bit, but sure, 2, maybe, yeah, it's not, yeah, 2. So it would be 2t 8t square minus 13 equals 0. So now we just need to find solutions for this. But before doing that, let's think what it gives us. We found the derivative. But why I wrote equals 0 there? Why I did that? Well, it wasn't there when we were looking for derivative, right?
It was always equal to 0.
Pardon?
It was always equal to 0.
Because I'm looking for the value of the derivative when it also has y, or the value of the function, equals 0, because it would have the shared point with my function, and this point would also have coordinate 0. Do you catch it?
No, can you explain it one more time?
Look, imagine I have some function here. It's force power, so it's gonna be, I don't remember. Let's say something like this, okay? Wherever, we don't care, because look, if I'm asked where is this function, look here, equals 0, it means t, which is x, in fact, variable, right? And here we could have s, distance, okay, or y, no, doesn't matter, or FOT. It's just different ways to name it, okay? And we have, let's say, function of distance. Then derivative, when derivative equals 0, we know that the slope equals 0. So we need, in fact, to do what? If now we would like to implement derivatives, what we know about them.
Should we do the power rule again? I don't know. You do it 8. You do 2 times 8t subtract 0. I'm guessing not.
So in this case, we can see that the derivative is not just a line. Function of the derivative is not just a line. However, we can find the derivative of a function when coordinate of a function equals 0, basically. But we're looking for derivative at this point, right? To know the slope of a line at this point, and if we know this point and her coordinates, what's happening then?
We could plug it in for t.
No, you already you know y of this point. You see, you know s coordinate or y coordinate or f of x value. You see,
Oh.
it's given to you here, f of x equals 0 or f of t equals 0.
Then you sub it in for y. I don't understand. You put it for 0. You take the y value and set it equal to set that equation equal to 0, or set the equation equal to that y, and then rearrange it.
That's one idea.
I don't know how you.
Again,
understand.
yeah, I'm not telling guys. Maybe I'm tricking you, but I'm just giving you scoop because this takes much more time to, improve. We're just looking at possible tricks we can do with functions here. You see, here we already trying to implement our knowledges about derivatives.
We're trying to solve for t, right?
Yes, we're trying to solve for t.
And we know the y. How do we? What is the y value of that point?
Y value of this point would be 0. So basically, this function equals 0. But you know what? As exponential function,
Oh,
it
so
would have many zeros, many points where it equals 0.
so would we look at the 0 on the graph, and then find what point that is? Like the 0 on the y graph and find the x.
Basically, yeah, that's graphical solution. You would plot them on the same uh on the same oh my god, what is it called? Remind me. How do we
Axis.
call this? Axis or discrete okay. I'm just trying to remember that it's on the tip of my tongue, Sorry. So yeah, that's a graphical solution. So now we're slowly expanding our knowledges. Now we can analyze both mathematic calculations and graphical expressions. That's why it's important to be able to sketch the graph, because most likely, for example, this type of equation, up to certain power, you still know how they generally look, and there are many ways of sketching them. And I'm pretty sure you sketched this type of equations before. Did you?
Yeah.
So let's think about it. How would you solve it without derivatives?
Oh, the equation?
Yeah, because Yusuf didn't find the solution
Right.
from school.
The way I would solve it is, can you clear a room?
Yeah.
This way might be, if Yusuf didn't learn this in school, and it might be a bit more complicated for me saying it, but I'm gonna try it. So, we have to find a factor of 9, we could just, it's like a guess and check at the beginning. You could plug into the equation that would equal to 0. So in factor of 9, they would be 1, -1, -3. It's all plus and minus. 3 and 9. So then we take, it's kind of just guess and check in the beginning. And what I found was 1. If you go on your calculator and plug 1 to the power of 4 times 4 is subtracted by 13 times 1 squared plus 9, that equals to 0.
Wait. Are you solving it all in your head or are you writing it?
Well, I already solved it. And
I don't understand your approach.
well, I'm not done yet though.
Oh, okay. Sorry.
So then we have 1 right here. And then we would take that and we take the coefficient of each term. So it would be 4. And you notice how in between the 4 and the 2, there's no cubed. So we don't want to jump straight to the 2, so we're going to have to put a 0 for a skip kind of. We can't just skip right to cubed. And then we have the coefficient of the next one, -13, and then last one is 9. And then we would bring this one down. And then there we go. And then whenever a number is under the line, you multiply by the number outside up here. So then you would multiply 4 by 1. You bring it to your 4. Then whenever it's inside, you add. So 4 plus 0, 4. Multiply by 1, 4. Then you add by -13, -11, 9. Multiply by 1, -9. And you get 0. And that's your remainder. You don't really focus on that. That's kind of a dead number now. And then you have your x. You take the 1 and you flip the sign when you plug it in to the thing. And then you have 4. And then you notice how you could do 4x cube, it has to be cubed, plus 4x squared, subtract 4. And then now you have this, it's still a cubic function. So what you'd have to do is do it again. Ignore the x, subtract 1. You'd have to look at the -4, find a factor that would go into the equation. So if I try 1 cubed times 4 plus 1 squared times 4, subtract 4, that doesn't work.
Oh, and you're also saying that this function equals 0 when x equals 1.
Yeah. So that would equal the first one is 1. So 1, if you plug in 1, that's one possibility.
Yeah, and if you look here, in fact, it's true.
Yeah. And then whenever I get what's in the bracket, whenever I divide that down, it'll give you it'll give you more solutions. So if I do 2 cubed times 4 plus 4 times 2 squared, it doesn't work. Let's try -1. -1 cubed times 4 plus -1 squared times 4.
Are you solving?
Yeah, I'm just trying to find that number. Um, um, hmm. Let's try 4. 4 cubed. No, 4 negative cubed times 4 plus 4 negative squared times 4. Did I do this? Did I do it wrong? 13 negative plus 4 negative 9. Oh, that's why. Sorry, this is not supposed to be 4, it's supposed to be 9. I just had it messed up right in here. Okay, so it's gonna be, so then let's try 3. Negative 3 times 4 plus squared times 4. Plus 4 negative 1 squared times. Give me a second, I'm just trying to find it out. Negative, so 3. Let's try negative 9. Oh, you know what?
What?
I think I had a small error. I think it should be 9x at the end. So then, oh yeah, so then if we factor out an x,
Guys, I have another suggestion. What if we treat this whole part as one big quadratic function? So it's something a square. So, and this something would be because here we have minus 13, you see, minus 13t squared. If we would have here, for example, 2 times 3, this looks like a good couple, right? Times 3, and 2 times 3 equals 6. And here we have 13. So let's write it like 4t to the fourth power minus 6 as we want it, right? Plus 9. And here we write minus 7t square. Now we can rewrite this part as, sorry, we can write it as 2t square subtract 3. Oh no, wait. Here it's supposed to be 2 times 2. So 2 times 2 times 3. You get
No.
it? Because here it's 2 times a b.
This question, you're gonna have to use quadratic formula for it. So it's not gonna give you whole numbers to find the points.
So let's finish. Right now I'm basically what I'm doing, I'm grouping up the components in this equation, right? It's
Mhm.
not against the rule because it's minus and this is plus, it's not product or something, right? So
Mhm.
let's simplify it and see what we can. It's 13t square. So here, if we have 12, which is 2 times 2 times 3, right? And here we have subtract t square. Now we can write this as 2t square subtract 3. Subtract t square equals 0. Right?
Hmm.
So now, first of all, we can write it. What gives us 0? The difference of two same stuff. So now we can say that 2t square subtract 3 equals t square. Try to solve it for this. You see?
For what?
Um,
Try to solve what? That one? Oh.
did you get my, oh, here we have a square.
Mhm.
And here we have square. So
Yeah.
square of something subtract square of something equals 0. But
Mhm.
this something should be equal.
Oh, okay.
Do you get it?
Yeah, I think I
So,
got it now.
so here not t square but t.
Yeah.
I don't understand that part. Can you explain that part again?
So actually I think we would eventually reach this if we would keep on simplifying, because now we can simplify it as difference of a squares. You see it? And when we simplify it, we're gonna get to the power lower. Right?
Yeah.
When we factor it. Look, I'm not doing anything extraordinary here. I just regrouped the components. First thing that I look at, can I make it more convenient for me to use that approaches that I already know? Do you know the quadratic function when you can like convert it into something raised to the power 2?
Pardon me?
This step, do you understand? This step, why this equals to this?
Well, you factored a T2, didn't you? It looked like you did.
What?
No. Can you explain that part?
You see, that's what I'm asking. Ask me questions. Don't hesitate, because if once we go forward, it's so painful to make a step back, okay? So look, Let's bring everything to one piece. Boom. And this way, we don't need this anymore. This school stuff, it's boring. It's not interesting. We're gonna use some advanced techniques. Here, this is initial equation, right?
Where? That one?
This one. This one.
Yeah.
So now, let's take a look at what we got here. First, I noticed that it's almost a perfect formula of a different square of a difference, right? Almost. Because here, root of this would be 2t a square. Root of this would be 3, right? Guys?
Yeah.
And here, if I have 2 here, 3 there, I supposed to get 12 eventually, right? But I got 13t squared. So I just take and break this into 2 components, minus 12t squared minus t squared. Have you have never used this method before?
No.
So look, you see here, I basically split it up in 2 pieces. That's not forbidden, right?
I guess not.
Like, why you guess? Because you can write 12 as 6 plus 6, right?
No, I guess not.
So now using that, we are converting this into the square of a difference. You see? Do you know this formula? That a square subtract 2 ab plus b square.
Yeah.
Do you recall it?
Yeah.
You're supposed to know this because you see, we spend so much time on ladder method. I don't know, but everything is on tips of your fingers. You should be able to recognize this pattern, right? Because you did it so many times. This is a really easy formula, isn't it? Difference, a square of a difference. And it was right here. And now we have 2t squared minus 3 a square minus t squared. And now we can write it as 2t squared minus 3 remember? What's next? Minus t times 2t squared minus 3 plus t. Isn't it? Isn't this difference of a squares?
Yeah, it is.
And now nothing is against us to open these brackets. Inside. Why can't we? Of course we can. We say 2t squared minus t minus 3 times 2t squared plus t minus 3 equals 0. And now we treat it as 2 quadratic functions. And this you can solve as you wish, Vieta or sum and product. Because product of this, if 1 is equal to 0, is going to be equal 0.
So it's gonna be.
Right?
Well,
Do you know, it's important. You understand that
yeah, I
if we find
understand it.
solution for this when it's equal 0 and we have product of these 2 functions, no matter what value the other function takes, unless it's in denominator and it also could equal 0. So imagine if after these transformations, you would get 2t squared minus t minus 3 divided by 2t squared minus t plus 3, okay? Just for example, here you have to consider values when this one equals to 0, and you would say that t should not take those values. And again, and you have to compare it with your initial function, because if it satisfies the requirements of your initial function, for example, if your initial function was like t square, okay, just an example, and you're getting this out of it, and you say t cannot equal this and that, you say, wait a minute, but the initial function was defined at this point. Why can't I do it now after all of my transformations? And if you can't do that, or some properties of a function drastically changed, it means you did a mistake somewhere. I'm here, I'm just trying to teach you of the pattern recognition in math, that everything is interconnected.
Yeah, I got it. And then you could solve it. I solved it myself. I also figured out I messed up on my method here. I just
And,
realized how.
and you see, and it's not because you are bad. It's completely not your problem that you made a mistake with this method, because it's overwhelming. You see, you need to
I
draw a
know.
table, you need to calculate this and that.
It's because I put 9 right away, but when I told you there has to be a placeholder right here in between this, I forgot to put it right here. So if you put the 0 here, and then you put the -9 here, and then you bring it down and you bring a -9 here, you'd have a -9 at the end of this, and you could solve it much easier, but when I did it, I messed up. So is it wrong to use this method?
Guys, oh, I've been talking and I've been muted.
Oh, that's why.
Wow. Okay, I was just saying that you asked me if this method is wrong,
Yeah,
and you didn't hear my answer, right?
no.
So this method is not wrong at all. This method is just overwhelming. It's massive. You can make a mistake while calculating it. And here we basically applied common principles that we knew long ago. The difference of a square, the square of a difference, and this all math is all about pattern recognition. When you see an equation and you say, "I've seen it before," I've seen something like that before, because just the numbers are different.
Okay.
You
But
see,
if
because
the equation is like really familiar to me, or like I'm really used to it, would I be able to use it?
you would like to keep using this formula, this method.
it helped because I know it really well. I did it.
You would have to learn new methods because with this method eventually your possibilities are going to reach their limit, you see.
Mhm.
This method would not work for other great functions, more complicated functions. In other functions, you cannot go for A, B, and C. For example, if we're dividing by function, if you're dividing by function, you're even more interested in finding the patterns to simplify it, to basically get rid of the denominator, right? In some cases, it's not impossible. So, and that's where your method wouldn't work so well.
Mhm.
For example, if you have the same equation divided by another quadratic equation, how would you use your A, B, C formula?
Fine.
Because you also gotta check if the function that you're dividing by is satisfying these values, if there are no problem with these values.
Okay.
And if you just basically look at this in a more broad way, analyzing it, that's what calculus is about. We're analyzing math, analyzing formulas, functions, their rate of change, instantaneous rate of change, their properties. And through these properties, we're getting a better understanding of how to solve complicated equations. So now let's read this discussion, and we're gonna finish in near 5 minutes, okay?
Mhm.
So we live in a world that demands we determine the best, the worst, the maximum, and the minimum. Through mathematical modeling, calculus can be used to establish optimal operating conditions for processes that seem to have competing variables. For example, minimizing transportation costs for a delivery vehicle would seem to require the driver to travel as fast as possible to reduce hourly wages. Higher rates of speed, however, increase gas consumption. With calculus, an optimal speed can be established to minimize the total cost of driving the delivery vehicle. So you can find this balance when your gain is not less than your cost. When you're basically spending per hour more than your, less than your earning for per hour. Comparing two rates of change, if you prefer. You get it?
Mhm.
So higher rates of speed, however, increase gas consumption. Consider both gas consumption and hourly wages. In this chapter, calculus tools will be used in realistic context to solve optimizing problems from businesses, applications such as minimizing cost, to psychology, such as maximizing learning. Case study, entrepreneurship. In the last 10 years, the Canadian economy has seen a dramatic increase in the number of small businesses. An ability to use graphs to interpret, how would you say it?
Interpret. Yeah, you said it right.
Interpret the marginal profit, a calculus concept, will help an entrepreneur make good business decisions. So now you know why this is all about. It's all about counting big numbers. A person with an old family recipe for gourmet chocolates decides to open her own business. Her weekly total revenue, TR, and total cost, TC, curves are plotted on the set of axes shown. Dun, dun. Let's zoom in. No. Why am I always You see, it's jumping through pages here. Oh no. So let's take a look at this graph. So what we see here, total revenue, boxes sold per week. Here we have two axes. First one is the number of sold products, right? Per week. And this is TR, TC, TP in dollars. So this is basically amount of money that are either spent or earned, right? So here we can see that per week, she sold basically 100 boxes. If she sells 100 boxes per week, she get TR, total revenue, of somewhere around 1,700, right? If she sold 60 boxes per week, we can see that her total revenue is about 2,400.
Mhm.
And now let's take a look at TC graph. TC, it's total cost, right?
Mhm.
When she sold 60 boxes per week, let me change the color. We have this much expenses, around 1,100. And when we have 100 boxes per week, we have this much expenses, 1,900. You see? And while we earned 1,700 when we sold 100 boxes per week, but we spent 1,900. So now we see that we would like to look when this graph TR is higher than TC, right? Because when it's higher, it means difference between these two graphs, it's our profit. Because revenue, it's not a profit. Revenue, it's like you bought something, you sell this, and all money that you get from selling is the revenue. But profit is the difference between the price that you buy and price that you sell. You got it? So based on
What
analysis
does
of
the red line stand for?
red line stands for total cost.
Okay, and then the blue.
Blue stands for total revenue.
Okay.
How
Yeah.
how much money we get from selling this product.
Okay. Yeah, got it.
So now let's take a look at the questions. We analyzed this graph. We saw this interesting dependence here, right? That the more you selling boxes, the more total cost of your production. But after a certain moment, you are not earning more, right? You start earning less, but the price is keeps growing, keeps growing, right?
The no, which one?
TC, total cost. Total
Yeah,
cost
that
always
one
grows.
keeps rising.
Yes, and this one at some point it changes its direction. You see, it like deflects from this point. It like deflects down. So before we look at these questions, what I would do here with this graph, I would find this point, top point of the curve, to stop right there, because the point where my total revenue is the greatest, but you gotta make sure that your total cost is the smallest possible. So basically, so your difference is greatest. So now guys, let's take a look at the question, what they say. And I would like you to answer this question at the beginning of the next class, okay?
Okay.
Yusuf, are you with us?
Yeah.
Great. Sorry for leaving you alone for so long. You have any questions?
Oh no, I think I got it.
Yeah, I was just so confident that you got it.
Okay.
No, sure, no questions at all?
Yeah, I think I got it. If I have any question, can I send you text or?
Yeah, just
Okay,
email me.
thank you.
So, what sales what sales interval would keep the company profitable? What do we call these values? So, what sales interval? I would say interval where the total revenue is greater than total cost, right? Because here we see if we make two less boxes, total revenue is still less than total cost and we are losing money, right? And here we're gonna keep losing money. But here, you see, we have more of a total revenue. Total revenue is higher than total cost. So this section from, let's say, 10 boxes to 90 boxes would keep the company profitable. Unless you sell somewhere between this amount of boxes, your company is profitable.
Wait, so the cost is the red line. I just realized how, if like the cost, like how much it costs to buy the chocolate.
No, total cost, it means cost of production.
Okay,
Here,
how does
a
how is that?
person with an old family receipt for gourmet chocolates decides to open her own business. She just opens some business, and her weekly total revenue, how much this business makes
Yeah,
per week, and total cost, how much this business spends per week. Two curves are plotted here. Red one is how much we spend, and blue one is how much we make. But our profit, like clear difference between, like you earn 1,000, but you spend 500 to earn this
okay.
1,000.
So then
So you
in like week 80, she spent $1,800.
no, it's not week 80. It says this is the graph
Boxes
or
sold.
dependence of, you see, X is not a weeks. X is boxes. So
Okay.
this is amount
Boxes
of
per week.
boxes.
Okay.
Yeah.
So after 80 boxes, she'll make $180 on the red line. No, she'll make no, she'll make a. You have to look at the blue line for that.
Here, this line, you see, it's
For-
slower
For 80
than
boxes, she spends 1,800.
yes, to make
Okay.
100. No, to make 100, she would spend around 2,000. You see, it would be somewhere here because here this is 100. You see it? This is
Yeah.
100, and if we go here, we see it's around 2,000.
Yeah.
If she makes 100, but instead, if she makes 90, she would get into equilibrium point when
Yeah.
total cost equals total revenue.
Okay.
So
What is the sale that would keep the company profitable? What sale interval would keep the company profitable?
yes, say
So,
this 10 to 90.
pardon me?
The range of sales from
Oh,
10
the
to
range.
90,
Oh, so that one they're asking for range. Yeah. Okay. Yeah. 10 to 90.
like sales interval. Interval. What is
Yeah.
interval? It's a range
Okay.
from 10 to 90.
Oh yeah. Okay. I'm just reading the questions now. Yeah. I could do these.
So please go ahead, do it at home, and I'm going to post some home assignment for you, okay? Because I would like you to remember all of this difference of a square functions, because without them, we cannot use ABC. We can't.
Mm.
Just